Hi guys, we'll be starting in like 5 minutes. I'm just setting some stuff up. If you can hear me, can you type in a comment or something in this page, the event page? Great. So let's wait for like 5 more minutes for other people to join. But before that, we'll be going through a bit about the community. So let me share my screen. So MLDLC is the community. It's machine learning and deep learning community. And this community was started because I personally was not able to find any community that was dedicated to machine learning and deep learning. There were a few communities, but they were not very active or they didn't have much content. So when I started this like 2 weeks ago, there was a really good response. We had like uh, we had like 40 to 50 members in 2 days, and around 100 people have RSVP'd for this event. So I went on and contacted a few authors who are into machine learning, and I was trying to find if we will be able to get some good articles from them. So the whole point of this community is to create and share content that is totally focused on machine learning and deep learning. So I'm right now I'm working on a website, and you can find the website at mldlc.xyz. So this is our website, and there'll be much more content. This is just the basic page that I put up, and we also have a YouTube channel, in which we will have much more videos. It's just started right now, and there is the blog, which you can find. I'll post the link in. I've posted the link in the chat, in the Google chat. If you find it in the right side of this Hangout. So this is one article which focuses on understanding the concepts of machine learning in 1 week, and this was written by a friend of mine called Per Harald Borgen. So this article gives you some kind of the basic information about how you can really understand machine learning and like kind of understand it and start working with it. This is a bit high level, but still, if you are really into it, this is a very good article. And we will have much more articles coming into this blog, and I would really love to have you guys to write articles and share content in this blog. So you will be getting a lot of exposure as well as helping others learn. So we have the website is ready. I'll be adding more content in this, and also as for this community, we'll be having an event every single week. So the plan is to have other developers like the experts in their field, but who are related to the machine learning field, the ones who are really working in the industry. They'll be joining with me too in order to present webinars, or we'll start doing even the live events too. We are planning to ask some companies for the venue, and we are going to host some live events too. So I guess that's enough of an introduction. Let's start with the webinar. So this webinar will be focusing on the core, the very basic concepts of machine learning. This is intended to complete beginners in machine learning. And each webinar that we do in machine learning or any other topic will be posted as a video in the channel. So complete beginners can, like start from scratch. So that's the idea. So this webinar today we will be going through the basic concepts of machine learning, how machine learning basically works, what are the concepts, and a very popular tool in Python called Scikit, and how to use Scikit, some of the documentation with Scikit. We'll go through some examples with Scikit. So this session will be around 30 to 40 minutes, and we'll have like 10 to 15 minutes for Q&A. So that's the plan. Let's see if anyone else has any questions. You cannot understand machine learning within 1 week. That's true, but you can understand the basic concepts of machine learning and you can start working with it in 1 week. You can definitely do that because I did. Okay, great. So a quick introduction about the MLDLC, which I gave you already. So if you have any emails, if you have any article ideas or topics that you would like to present with me, you can send me an email at info@mldlc.xyz. So a quick introduction about me. I'm Manish Shivanandan. I've been in the industry for around 5 years now. And I'm an engineering dropout. I dropped out of engineering and I was a freelancer from my second year, I guess. Yeah, from my second year. And I was a freelancer for 4 years. And then I joined a company called Adapt. So I'm right now a data scientist at Adapt. I deal with all the code that they do, all the work that they do with artificial intelligence and machine learning. And the company is in UK, and I'm part of the team, the developer team, which is spread across the globe. I work from home right now. So I've been with Adapt for the past 2 years. I've been dealing with all their machine learning work. So machine learning is all about data. If you ask the experts in machine learning about what machine learning is all about or what data science is all about, they say the first thing that you should ask is, what do you want to find from the data? It's not about the algorithms or it's not about all the concepts and mathematics. It's all about data. If you have the data, what are the types of insights that you're going to find from the data? That's the question that you have to answer. So when there is the question, you can use all the algorithms and techniques and tactics in order to find the solution that you want with the data. So that's what data science or machine learning is all about. So I'm going to try and explain to you the very basic concept of machine learning in a minute. Let's take a simple data set, which is 0, 1, 2, 3, 4, which we can call as the domain. And y is 0, 1, 4, 9, 16, which is the range. So a human can easily find that the equation that governs this x and y is x square. So 0 is 0, 1 square is 1, 2 square is 4, 3 square is 9, and 4 square is 16. So this is the equation that governs. So this data set has a pattern. It's very important to see that we need a data that has a pattern. Not all data can be fed into machine learning algorithms. We need data that has patterns. And that pattern can be expressed. Any pattern in the data can be expressed with the help of an equation. That's the concept of machine learning. And if you look at this data, its equation is y equal to x squared. So if my x is going to be 5, my y is going to be 25. If it's 6, it's 36. This is the concept of prediction. When you can get the equation that governs the relationship between the domain and the range, you can do the predictions. But there is a catch in machine learning. This data set is totally perfect, but we won't be getting perfect data in all cases. Most of the data that we will get will be imperfect. There will be a lot of missing values. There will be a lot of errors. There will be a lot of you can never get clean data in a real world environment. So that's where your skill as a machine learning engineer comes to play. So it all depends upon how much you clean the data, how much you take the data and display it in charts and find patterns. And once you can really see patterns, you can use algorithms. There are complex algorithms and there are simple algorithms. So you can use different algorithms and see how you can find the equation that governs this, the input and the outputs. So once you're able to find that, life becomes much easier because you can start predicting, or you can really. There are uh, a lot of examples when it comes to the real world usage in machine learning. If you look at Amazon, you can go to Amazon and start shopping. After some time, Amazon starts to show you uh, the related items that you might want to buy, and most of the time, it will be things that you might be interested. So there is a machine learning algorithm working behind it, which which kind of tells them that these are the kind of stuff that you might be interested in, because there will be a lot of people shopping. They will have much more data, and people related to you, people who have the same browsing habits or shopping habits like you, they will be pulling information from them also and feeding to their algorithm, and that algorithm will know better than you what you want. So this is the basic idea of machine learning, how it works. And there are three types, which I'm sure that you might have heard, but this will be, I believe, much simpler explanation. So supervised, if you're going to give the inputs and the outputs to the algorithm to learn, it's called supervised. It's like teaching a kid about some concepts and asking questions back from him, asking questions to that kid. So in supervised learning, you'll be this is an example of supervised learning, because you're giving the system both the inputs and the outputs. One example would be predicting stock prices. Machine learning is used extensively in stock prediction, and there have been many advanced models in order to find how the stock will be moving, because stock market is very volatile and uncertain. So the more you can find certainty in the stock market, using algorithms, the more money you make. So machine learning is used very much in the stock market. So this is an example of regression. Using historical data, we can really predict how the stock might move in the future. So this is used even for day trading. Day traders use machine learning algorithms in order to guess where the stock will move in order to make money. The next idea in machine learning is classification. So an example in classification would be, let's take Amazon again. If you are shopping with Amazon, the Amazon's algorithm is able to find clusters. So clusters is group of behaviors. For example, men will have a type of behavior where they shop for things, and women will shop for different things. This will give Amazon clusters from which they can differentiate. Okay, this is a group of people, and that one is a different set of people, and they can analyze these set of people have common behaviors and cater to their needs. So this is how classification works. Uh, Another example of classification would be, it'll be bank transactions. So if you can just look at bank transactions, there will be a lot of transactions which are happening normally, and some transactions which will have spikes, like there are too much amounts that are being transferred, or there is a sudden withdrawal in the from the account. Those kinds of those are red flags in the banking department. So these are some of the examples where classification is really useful. And when you come to unsupervised, when you're going to give the system, I think I mixed up a little. I'm sorry. So classification and regression are two examples of supervised learning, where you will be giving inputs and outputs. So regression, I told you. In classification, the output is discrete. In regression, the output can be anything, like it doesn't have a limit. It can be 0 to anything. Whereas in classification, the output is just either yes or no, or 1, 2, 3, these kind of discrete values. So when it comes to classification, another example, a very common example in classification is tumor analysis. We process a lot of images of people having tumor, and when there is a new person coming in, and when we take a scan of this tumor, we can easily find if that is life threatening or not. That is one type of classification example. And when you come to unsupervised, this is the concept of clustering. We can classify people based on gender, how they shop. We can classify them based on the things they buy. There are a lot of ways in which classification can be applied just in this shopping problem itself. If you take another example, you can analyze the people who are working in a company and see how much hours they are working, and based on that you can group them into different categories of people, and you can set different rules for them or timings for them. So these are some examples in which clustering can help. And the third is reinforcement learning. So in this part, we saw that there is always an equation that describes a pattern in data. So this equation can be made much better by constantly feeding in more data and more analysis. So in this set, once we get the equation, we are going to do all the predictions. But in reinforcement learning, as we get more data, we keep refining this equation. So that is the concept of reinforcement learning. So the more we train, better prediction that we can get. So do you guys have any questions? You can either post it in the Google Plus page or the chat. Okay, great. And the final concept in machine learning is neural networks. So neural networks is the science of making the algorithms to decide. So basically, all the other algorithms helps you to find the equation that governs the inputs and the outputs. Whereas in neural networks, you can program the neural networks. The whole concept of neural networks is based on decisions. For example, let's assume that a pattern which governs the data can be expressed in two different equations. A neural network can decide which equation can do a much better job than the other one. So neural networks, so these kind of neural networks have given rise to the concept of deep learning. So when we combine a lot of neural networks together, we get, for example, let's assume that there is the common problem which deep learning solves is image classification. So let's assume that we are going to feed the system with a lot of images. If we feed the system with a lot of images, it cannot really make out anything from that because the images are very complex for the algorithm to break down. So what we do in this case is tie together a layer of this algorithms, and they can break down each part of the problem into different sections, and each layer solves one problem and feeds that data to the next layer. So if we quickly do a search for deep learning, so if you see in this example, there is a face, and this face is broken down into small pieces, and those are broken down into other small pieces. So this is basically how the deep learning works. We combine a lot of neural networks and give each layer a small subset of the bigger problem. So each subset solves that part and feeds the output to the next part, so that the next part understands much more about what the problem really is. Here you can find another image which shows how it works. Yeah, we feed a lot of dog images. So each layer breaks it down and it classifies whether it's a dog or a cat or or whatever the animal is. And again, when you feed in the face of a dog, it can make out that it is a dog. So this might sound very abstract, but this is the high level concept of how deep learning works. It's neural networks. So you can if you so the simplest way to explain a neural network is the same as this one. So in this, we have used a linear regression. Let's assume that this is one neuron, which finds that the equation that governs these two data sets is y is equal to x square. And if we stack these kinds of algorithms together, if we can break down, for example, images are broken down into pixels. So when we start finding the patterns between the pixels using a lot of these algorithms stacked up together, that makes a neural network. So there are much more complex algorithms which are used in neural networks. The common one is called as the logistic regression. Logistic regression is used a lot in neural networks. This is a very efficient algorithm. It helps us. It's 1 by 1 plus e power minus x. So this helps us to find the values between 0 to 1, which is very useful in neural networks because the decision can be taken as either 0 or 1. So 0 means no, 1 means yes. So this can be used in both classification as well as regression problems, because this offers us two advantages. Because one will be it can say whether it's 0 or 1, the output is either 0 or 1, or it can range from 0 to 1. So there are a couple of tools which we can use, which are in Python, which are really popular. One is Scikit-learn and the other one is TensorFlow. TensorFlow is for deep learning and Scikit-learn is for normal machine learning. Scikit-learn supports some neural network algorithms, but TensorFlow is the one if you want to really get into deep learning. So let's take a tour of Scikit-learn. If you guys have any questions or you want to stop me in the middle to explain something else, you can either post a comment. Yeah. Yeah, in Scikit-learn, I can definitely give you examples, but if I go to the examples right away, I'm not sure how many people can catch up. But let's definitely do a session fully focused on Scikit, like doing some of the trying out some of the complex algorithms that we have, taking some real world data sets. There are a lot of data sets which we can use with Scikit. There are real world data sets. I'll give you a couple of examples. I wrote a couple of articles which deals with using data and doing analysis with those data. So this is ranking keywords in Hillary Clinton's emails. So what I did with this was to there was a lot of news going around on Hillary Clinton's emails. So this was a data set that was available publicly, and I took these emails and did some analysis and found the list of keywords which are commonly used, and a few predictions, like a few natural language processing algorithms which will help us to understand if the email is written by Hillary Clinton herself. We can feed in a lot of emails which are written by Hillary Clinton, and then feed in a new email and see if that relates with how her writing style or pattern. So there are a lot of real world data set. This is another data set which was this is one live data set which I took from Twitter. So we can analyze Twitter. Twitter gives us the streams for free, around 1% of the streams for free, and we can do a lot of analysis with that. That's live data, live people tweeting. And I gave the keywords weed, I gave the keywords weed, ganja, and marijuana, and analyzed which are the states people tweeting about weed. So this was the analysis, and we did a visualization with that. So there are a lot of ways with which we can do data analysis and also use Scikit to predict that. So we will definitely do a session on Scikit alone. We will do a live coding session where we can sit and write the code to analyze real-time data and perform analysis with Scikit on that, analysis, predictions, and also natural language processing stuff. So yeah, Scikit is a very interesting library. It's very easy to learn, and if you can understand some of the basics, very little basics of machine learning. Now that I believe that you know some basics of machine learning, you can, if you know Python, you can definitely dive into Scikit and start browsing around. So Scikit offers algorithms for all the problems that we discussed. One is classification, regression, clustering, and dimensionality reduction is a concept where if you have like machine learning is machine learning is used in the industry extensively for much bigger problems where we'll be doing a lot of complex analysis and stuff. But when it comes to those kind of things, there will be much more dimensions. The examples that we saw had just two inputs. I'm sorry, one input and one output. Whereas in real world problems, we'll be having like thousands of inputs and a few hundred outputs. So for these kind of things, we need dimensionality reduction. Dimension is nothing but this is one dimension. If we have two inputs, it's two dimensions. So as the dimensions go higher, we will have bigger and bigger problems, and these can be reduced using algorithms, which Scikit offers. And model selections using the parameters. We will have a lot of data, but we can choose which data we want, or we can produce new data using combining some of the inputs. And pre-processing is the normal data cleaning and stuff. So scikit-learn offers a lot of algorithms for all these problems, and there are a lot of algorithms. It's one of the best library around. If you guys have any more questions, you can post in a comment. I'm going to get some water. Give me 1 minute. Hi guys, I'm back and I'm reading a comment. Neural networks, what is the output generated by single neuron? Is it a function or reduced input data set? It's not a function. See, in neural networks, it's all about weights and biases. I'm not sure how much you will understand this, but let me try and explain. So let's assume that there is a single neuron, and we are going to give it a couple of inputs and an output. So once it, I'm really sorry, someone is at the door. Give me 1 second. So yeah, in neural networks, what is the output generated by single neuron? Suppose, let's assume that we are going to give it a group of inputs and outputs for a single neuron. For each input and output that goes through the neuron has a weight. So if you look at the structure of a neural network, if you consider a single neuron, each neuron has multiple inputs and a single or multiple outputs. Let's assume it has a single output. So let's assume that there are three values that are going into the neuron, and it has one output. So in these three values, the neuron will decide which one is the best one in those three. If you ask me how will it decide, that's where we use a function called the activation function, which I showed you a little before, where in logistic regression, here in this, if the after the equation is processed, we will pass the output through this function, which will tell us whether the value is 0 or 1 or between 0 to 1. So whichever the one that is higher, has the highest value between 0 to 1, that will be taken as the output. So the this is what happens in a single neuron. So if you consider a neural network and take in the example of an image, there are lots and lots of pixels, and those pixels, when there are patterns in those pixels, they will be grouped together. And the reason for using multiple layers is to break down those images, as we saw before. So if it is going to be a car, we'll be breaking down the car into different parts, and each part will be trained. So it's easier to train it's easier to train a group of pixels, for example 10 to 20 pixels together, rather than a complete image which has like thousands of pixels. This is how this is how neural network is built. I'm not sure how much you understood it. If you still didn't understand it, I didn't share my screen. Okay, I'm sorry. I hope you can see my screen now. Okay, I have to explain that again, I guess. So this was what I was using to explain. in a single neuron, let's search for single neuron. Yeah, this is it. It has multiple inputs, and the job of this neuron is to decide which input is the best to use. That is what we call as decision making. See, in other examples, we have set of data, inputs and outputs, and the problem is to find the equation that governs the pattern. Whereas in this, it's a decision. That is why this is linked so much to brain. In case of humans, we take decisions. That is kind of simulated using the neurons. The neuron will have to take a decision. So let's assume there are like 5 neurons connected together. Each neuron will have taken a decision based on a weight. So this x1 will have a weight, x2 will have a weight, x3 will have a weight. And if you ask me how does it know the weight, it doesn't. We give that weight in random. And then as we give the neuron more and more and more data, these weights get adjusted. And at a point, these weights will no more will not change anymore, because we will have a kind of stopping point, which is a different function called as one common function used is called gradient descent. It is an optimizer function. It optimizes these weights for a neural network, and gradient descent is commonly used. So these kind of optimizers are used in order to help the algorithm to reach a stopping point. If we keep training the algorithm, it will keep changing. There is a problem called overfitting. This problem occurs when you train the data, when you train the algorithm too much. When you train the algorithm too much. So when you train the algorithm too much, it tends to have a bias. So if you see, if you see this, the first one is not a good fit. It's a bad fit. Whereas the second one is the right fit. Whereas the third one is the overfit. If you overfit, that leads to, if the algorithm learns too much, it has to generalize always. It has to find a pattern and generalize. If the algorithm learns too much, you're forcing it to learn too much. And that is the problem of overfitting. Your results will be false. It will appear to you like it's right, but it will be false. This is a very important concept called overfitting. When you start learning machine learning in depth, you will come across this a lot. So the skill of a real machine learning engineer is to find the algorithm that will rightly identify the patterns and give a right fit. It can have errors. It has to have errors. If it's 100% right, it's wrong. It has to have errors, and the errors should be minimal. If you have a large data set, a good machine learning algorithm, a trained machine learning algorithm will give you an error of around 5%, 5 to 4%. So if you have a 96% accuracy, you're doing really great. And if you're getting 100%, you're definitely, it's definitely wrong. You guys still can't see my screen? I have shared it. So I get a comment at 9:38 p.m. saying that my screen should be shared. So can you guys see my screen? Can anyone comment that you can see my screen or not? I'm sharing right now. Overfitting leads your accuracy to 100%, which is false. Yeah, great. Yeah, great, thanks. So overfitting, if you keep feeding too much data into it, you can feed too much data into it, that's not a problem. But if you keep tuning the algorithm, you will be having a lot of parameters when it comes to machine learning for tuning. So if you tune it too much and if you reach 100%, then it's definitely wrong. You should never do that. Yeah, great guys, thanks. So if you really are going into, if you really want to be a machine learning engineer and you want to get the basics really right, there are 2 courses I would really recommend. The first one is the machine learning course from Stanford, which is offered via Coursera. It's Andrew Ng's course. It's very famous. I'm sure that some of you, or at least, or I think most of you, would know about this course. But the problem is this course is really lengthy and pretty complex, and people don't really finish this, but do finish this because For me, it took like 3 times. I gave up 2 times, and the third times I finished it. And this is the best course if you want to understand the concepts of machine learning. It gives you all the ground up, all the basics. You'll be really strong in machine learning in no time if you try this course. It takes really 8 weeks, I guess. It's around 8 weeks, but if you're really into it, you can complete this in like 4 or 5 weeks maximum. And if you're starting out, and Andrew Ng teaches Octave. So Octave is really easy, but as you learn the concepts, you can use Scikit and try it out. Scikit has a lot of examples, a lot of amazing examples, resources, and everything. And this is common when it comes to Python. But in Scikit, there are a lot of examples. There are a lot of people who have used Scikit in real models. It is being used in a lot of web applications, engines, a lot of stuff. So Scikit is the kind of the proven framework in machine learning. So there are a lot of options for you. There are a lot of help in the community. So Scikit is the best if you're, and the best way to really understand machine learning is take the Andrew Ng's course, and as you learn the algorithms, try it out in Scikit. So in that way, you can easily understand and also start implementing all the algorithms. And the course covers all the core concepts, as well as the different variety of algorithms that you'll be using if you are a machine learning engineer. The next is Audacity's Introduction to Machine Learning. This course uses Python, and this is also easy to understand. And if you find this Andrew Ng's machine learning course hard, take this one first, Audacity's course first, and then try the machine learning course by Stanford. So in that way, that this one becomes much easier. But if you want to go into machine learning, you should definitely complete this course. Otherwise, there is no other place where all the information is really organized. This is the best place, as far as I know. So this wraps up our webinar on machine learning. So I guess I've been able to communicate properly. This is my first webinar, and the reason I thought of doing a webinar is because I've been doing events in Chennai Pi as well as in Geek Night. But the problem was I cannot really show you the code, or we cannot code together. If you sit and listen to the concepts in machine learning, you won't really understand. It's just like, it's really a waste of time, because machine learning is all about writing a lot of code. So we will be doing a session on Scikit, and I really wanted to write Scikit code today, but I think this video will be useful for absolute beginners who are coming into machine learning. So, and if we directly go into programming, it might be a little heavy for them. So the next session will be focused completely on writing code with Scikit. We'll be doing a lot of real-world examples. There are a few sites which you might be interested in. One is called Kaggle, which will give you a lot of data sets. And there are also competitions where you can compete with other machine learning engineers and see how you can compare with them. So in Kaggle, there are tons of data sets for analysis, and most of the data that they have is really cleaned and well kept. So you can directly take the data and start working with it. And when you start with these kinds of data, you can really see a lot of amazing insights. So it's all about seeing a lot of insights. If you look at the data, if you look at the raw data, you cannot really find anything interesting. But if you start playing around with it, if you start using algorithms with it and see what are the things that it has, what are the things it can do, you will really start to find things that people cannot normally find with data. That is the really fun part in machine learning. And in that way, you can really understand machine learning concepts very well, and you can start implementing real world solutions with it. And machine learning is an amazing, is a very amazing field, because one thing is, let me read a couple of comments. Yeah, thanks, Anand. I would personally suggest people to go ahead with Professor Ng's course. I'm into my 7th week currently. It really builds your basics. Yeah, you're definitely right. But we cannot assume that all the, especially for starters, the people who are coming for the first time into machine learning, professors and NG's course is not recommended because it's hard. It has a lot of mathematics. So it'll be hard for you. If you are good with math, then you're cool. There's no problem. I'm a dropout, so I didn't take any math classes. I skipped all my classes in college. So Audacity's introduction was easy for me, and then I went into Andrew Ng's course. So that is kind of recommended if you are really new to machine learning. But if you have a good math background, definitely you should take Andrew Ng's course. Also go for Audacity, inferential and descriptive statistics. They build your basis of statistics. Yeah, definitely. You need statistics. I think I learned statistics before understanding that I'll be, or before knowing that I'll be going to machine learning. I just learned it because I just wanted to know how it works. But this statistics knowledge was really helpful for me. But for those people who don't have the patience, you can, directly go into the introduction to machine learning course in Audacity. So it's all about pattern recognition. So if there's one thing that I want you to take away from this webinar is that a data should have patterns, and only that data can be used in machine learning. And your job as a machine learning engineer is to find those patterns and fit them into an equation and do the predictions. So the more you go into the concepts of machine learning, the better sense this makes. It would be great if we can dedicate one session on making the best use of Kaggle. We can probably go together on a similar webinar and submit it on Kaggle, something like that. We can definitely do that, but we cannot really trust all this power and everything. So when we are busy writing code, if the power goes off, then it's really a headache, at least in my place. But we can definitely do a session on Kaggle and all the resources, all the things that we can. We will definitely do a session on Scikit, and Scikit session we will use Kaggle, and we will take the data set from Kaggle. So I guess that'll be good for us. We will take a good data set from Kaggle and see what are the things that we can do on the data set with Scikit, some of the predictions. So the next session will be on, most probably, on D3 visualizations. So D3 is an amazing framework with JavaScript. So this I wrote all this with D3, and if you see some of my blogs. So D3 is, most of the machine learning engineers use D3 for visualization. After we do all the stuff with data, we can do, as a machine learning engineer, we can do whatever we want with the data. But if you want to show the output to the people, the normal people, or your clients, or whoever it is, you need a good visualization library, and D3 is the best one. And D3 is in so much demand right now. There are not a lot of people who know D3, and if you learn D3, that's a really good skill set that you should you can put on your resume. So these are some of the charts that I worked on, I think around 6 months back, when I started working with D3 for my company. So this is a static chart, but there are a lot of amazing live charts that you can see in D3. Let me show you. So if you see this website, it's called IP Viking. So IP Viking shows you which country is trying to hack which country, and this was built by D3, built with D3. So you can see that all the countries that are trying to hack other countries. And this is the first visualization that I saw, which was done with D3, and I really fell in love with D3, and then I started to learn it. It was really cool. And D3 is a little tricky to understand, but once you get the point of how D3 works, it's really fun, and you can build super cool animated charts with it, with all the data that you can generate. D3 next session is very, very exciting news. Yeah, definitely. Next session is going to be on D3, and we will really get into coding. This will not be an introductory level course. You should learn. You should know a little bit of JavaScript. A very basic JavaScript is enough. If you know a little bit of JavaScript, we can you will be able to really understand how D3 works. There are a couple of tricky points in D3. That is, those are the barriers for entry in D3. That makes really hard for people to learn D3, and those are the things that we will really cover in the next session. We'll be going through some of the methods called enter and exit on all that. So I'll post all the details in the meetup group. So for those who missed the first few minutes, the reason I started this meetup group is to contribute, share, and learn together. So this will be called as MLDLC, the machine learning and deep learning community. And I built a website which is very basic, but it'll be updated. mldlc.xyz is the website address. And there is also a Medium blog where I have partnered with a few good authors in machine learning who will be helping us, who will be giving us articles to post. And there is also a YouTube channel, and this is our meetup group. So YouTube channel will have much more content coming in. So it will be great if you guys have any ideas, or you guys have any articles, or anything that you can contribute to the community, you're most welcome to do it. It'll be shared in the, if it's an article, it will be shared in the blog. If it's a video, it will be shared in the channel. So you'll be able to get a lot of exposure and also help other people learn. So if you have any questions, you can post it. I think we have a few more minutes. I know Python, but don't know anything about JavaScript. Python is enough for D3JS? No, definitely not. JavaScript is really easy. I worked with JavaScript. I have been working with JavaScript for the past three years. Yeah. Medium blog link. Yeah, definitely all those links. Let me post all those links first. If you go to mldlc.xyz, you can find the Medium blog on the top right. mldlc.xyz. That's the website address. If anyone still can't get it, you can tell me. I can post. Let me post here. mldlc.xyz. And Medium blog will be served as blog.mldlc.xyz in a couple of days. So I am yet to get the subdomain details from Medium. So I'll link it to that as a subdomain. And this presentation, I'll post the link for this presentation in the meetup group. This is public already. Yeah, so if you guys have any more questions, you can post it. We have a few minutes for questions. And if any of you are interested, as a professional ML engineer, what topics do you think in ML? You should be familiar with, you should think of it as like your personal framework. See, I've been working with JavaScript for the past 3 years, and even for all the work that we do in our company, I use JavaScript, even though JavaScript is not at all the recommended language for machine learning. Since I have understood the concepts, I can implement them in any language I want. So that is the thing. It's not about using Scikit. Scikit is kind of an easy wrap around all the algorithms. Scikit is really easy to learn. Whereas we have been using Node.js in our production environment. So I'm forced really to use JavaScript. Otherwise, I would love to use Python. But since we have all the stuff built in JavaScript, we have to use JavaScript. And JavaScript is really fun when you start learning it. If you ask me, if you need a lot of JavaScript to learn, you don't need much JavaScript. If you can get very basic JavaScript, what JavaScript is, how the callbacks work, that's all you need. Just very basic JavaScripts. If you have worked with Python, it's easy to learn JavaScript, definitely. If you get the basics from W3 schools or something like that, you can understand D3. And D3 is a really, really valuable skill set for a machine learning engineer. So if you can invest a little bit of time with JavaScript, you should definitely do that. So what topics do you think an aspiring ML engineer should be familiar with? In terms of topics, all the basic concepts and some algorithms which you can use for those concepts. For example, for regression, you should know a couple of algorithms. For classification, a couple of algorithms. For all the basic concepts, if you can know a couple of algorithms and you can take a data set and start working with it, that will be best for beginners. If you're going into really, if you're going to be a really complete data scientist and you want to work with much bigger problems, you should learn more concepts, but they are not really necessary, because as you go into a company and start solving problems, you'll be able to tweak your framework. You'll be able to find a lot of resources, much more resources. So you don't need to be an expert before joining a company. It's best to learn the basic concepts and then go into a company and then start picking up from there. Because machine learning is a relatively new concept. There are not much professionals around here, and companies, especially in Chennai or Bangalore, they're just starting to use machine learning stuff. So the demand is high, but there are not much professionals. If you take a language like Python, you need to have a good working proficiency before you join a company and call yourself a Python engineer. Whereas in machine learning, if you know the basics, you can work with data and you can find some a good you can do a good job with data. Then that's enough, as far as I know, because I've been seeing all the some of the job postings and the skill set, and some of my friends are company owners, CEOs, so they'll be telling me what are things that they are looking for in machine learning engineers. Their problems are not very big. Their problems are very basic. They are trying to find what their customer wants based on the browsing data and history. So that's not a big problem to solve. That's kind of easy to solve if you can understand the basic concepts. So right now, I think you don't need to be an expert in machine learning in order to get a good job in this field. If you can understand the basics and work with it, that's enough, I guess. Any other questions? If you have any questions in the future, no problem. You can post it either in the meetup group or send an email at info@mldlc.xyz. So I hope you guys enjoy the session. Do comment how this session was. If you think this session was great, I'm really thankful. Especially if you think this session was not good, please post what are the things that can be improved. Because this is the first time I'm doing a webinar, and I could have set up all the stuff much better, but I couldn't. So if you have if you have the comments on what are the things that didn't go well, what are the things that you didn't like, or the things that we can do much better, please post it in the forum, and that will definitely be improved. That's 100% will be improved. So I'll be posting the details for our next session in the meetup soon. So see you guys then. Thank you so much for your time. Bye.